In this video, we're going to use systems of equations to solve a problem. So let's take a look. Tickets to a production of A Midsummer Night's Dream cost $5 for general admission or $4 with a student ID. If 184 people paid to see a performance and $812 was collected, how many of each type of ticket were sold? I think it's always a great idea to start by just messing around with some numbers. Try to guess and check what's happening, and that helps you understand what the problem's about and how to set up your equations. So we've got two different types of tickets, right? We got a $5 ticket and we've got a $4 ticket, and we're trying to figure out how many of each type were sold. We know 184 tickets. It says people, but that's your tickets, right? That's how many tickets were sold. And $812 was collected. So let's just guess, right? So there's 184 people. Let's guess that 80 people spent the $5 ticket, and then 104 people got the student ID. So that has to add to 184, right? Which it does. So then we could check and see, we're going to see now how much money was collected. So if I take $5 times this plus $4 times this, how much does that come out to be? Let's see, that's 400, that's 416, that's $816. Wow, we're really close. So the right answer is 812. We could probably guess and check this right answer because we're so close. We're a little bit over, right? So, we need to make less money, so we would have fewer people doing the $5 one. Maybe let's try 75. What if 75 people bought the $5 one? Let's see, then this would have to be 184 minus those 75 people, which would be, what, 109. Okay, so we're going to take these 75 people, and we're going to charge them $5, and then we're gonna charge $4 for these, and let's see what that comes out to be. Let's see, 5 times 75 is $375 from those, and then 400 plus 36, and then we add those together, we get 811. Wow, that's really close. Okay, so we're about to guess and check the right answer. And sometimes that happens and sometimes it doesn't. But at least it gives you a feel for what's going on. So let's look at each of these two criteria. Our first criteria is that 184 people, there were 184 people. And so we see that over here in this example where we're picking our two values. They have to add to 184. So now it's time to define our variables. So let's let G equal the number of general admission tickets. Okay, we don't know how many of those there are. That was the $5 ones. And then the $4 ones was for student ID. I don't like to use S because sometimes my S's look like 5s. I'm going to let T equal the number of student tickets. Now, make sure you don't just write student. T equals student. Student is not a number. Your variables should represent values. Okay, so now we're going to write an equation. Well, as we saw over here, we need these two values here to add up to 184. That's the total number of tickets sold, right? That's what we were doing when we were guessing and checking over here with this 80 and 104 and 75 and 109. All right, then the other thing we did was we calculated the cost. Or the total revenue, let's say. So that's this $812 was collected. Now, how is that $812 total? How would that be calculated? Well, we get $5 for each general admission ticket and $4 for each student ticket, and that has to come out to be $812. All right, so there are our two equations, and now we're ready to solve. So we can either use the substitution method or the elimination method, And in this video, we'll do both, but let's see. Let's go ahead and start with elimination. It's all lined up nice. Let me make a spot to do that. All right, so for our elimination method, we want to add these two equations together and get one of the variables to drop out. If we add them together right now, g plus 5g is 6g, and t plus 4t is 5t. Our variables none of our variables dropped out. So let's say I want to get the t's to drop out. So if I want the t variable to drop out, then I need this t to be negative 4t. So when I add it to the bottom equation, it makes 0. I could also multiply the top equation by negative 5 if I wanted the g's to drop out. You have multiple choices here on how to approach it. I'll just do it this way. So if I multiply every term in the top equation by negative 4, I get negative 4g minus 4t equals negative 736, right? So remember, you got to multiply every term. The bottom equation, I'll just slide over here, make sure these are all lined up. Now it's looking pretty good. If I add these two equations together, I'm going to get 1g, no t's, and then whatever 812 minus 736 is, 76. All right, what does that tell me? That tells me I am going to sell 76 general admission tickets. Now we still need to find the student tickets. So we're going to go and we're going to use one of these equations here and plug 76 back in for G. It looks like the easiest would be we know that the general admission plus the student tickets has to equal 184. So if I take this 76 and plug it in there, I'll know that the student tickets is whatever 184 minus 76 is, which would be what, 108? All right, so we know that those two add to 184, so that's good. We could check also. Let's see. We have $5 for every general admission ticket plus $4 for every student ticket, and we're really hoping this comes out to be 812. Let's see. 5 times 76 is 350 plus 30 is 380. And then that would be 432. And let's see, we get 700, 811, or 810 plus 2. Yeah, we're good, right? 812. Awesome. Got it right. All right, so just for fun, I know, just for fun, let's solve this again using the substitution method. So you can see that this is really just as easy. Substitution method. Now remember, when you're doing the substitution method, you need to get one of the variables in one of the equations by itself. So we either need to get this g by itself. That'd be pretty easy. We just subtract the t over. Or we could get this t by itself. Well, that would be pretty easy. We just subtract the g over. We could get this g by itself. That's not as great because we'd have to minus the 4t and then divide everything by 5, and we'd have a lot of fractions. Same thing with this. If we got this t by itself minus the 5g and then divide everything by 4, we could end up with some fractions. You could do it that way if you love your fractions, but I would suggest getting either this g or this t by itself. I think I'm going to come over here and get the g by itself. If you want to get the t by itself, that's fine. I'll get the g by itself. And so I know that the general admission tickets has to be 184 minus however many student tickets. All right, so let's grab our other equation, which is 5g, this is the money part, plus 4t equals 810. So now for substitution, I'm going to take 184 minus t, and I'm going to substitute it in for g. That's the substitution because it's the same as g. 184 minus t is how we would find g. All right, so I'm going to leave that space there. Plus 4t equals 812, and I'm going to substitute in 184 minus t. All right, so now I have an equation with only one variable, which is t, so I can solve it. I'll start by distributing. So 5 times 184 is 920. 5 times t, and then I just bring the rest of this down. We can subtract this 920 over to the other side and combine these t's together. So we get negative t equals negative, what is that, 108. Well, it should be 108, right? Because that's the answer that we got before. Multiply both sides by -1, and we get t is 108, which is exactly what we got when we did it the other way. All right, so either method here works really well. And then if you were doing substitution, you'd still have to go back and figure out what g is. Oops, it's not 108. The total combined tickets is 184. And put the 108 in for t and solve for g, just like we did when we were doing the elimination method, and get 76. All right, well, I hope that helps. This is a great example of setting up an equation using both of these methods, and really take into consideration what we did at the very beginning of this video, is fiddling around with numbers, guessing and checking before you start trying to build the equations.